Hey everybody, welcome back to Mr. Clawson's biology class. We are going to be recording with a different camera today because the one on my computer is obviously not up to snuff for this lesson. So we're going to use my handy dandy cell phone and see if we can make this come out a little better. Today we're going to be discussing limiting factors with our fish tank from before, only with a little bit more detail. We want to bring up the fact that there are a couple different kinds of limiting factors. The main thing being that you need to understand is limiting factors are, of course, anything that limits the growth of a population of organisms, which means it's something that puts a cap on how many numbers of individual organisms can fill up in a single population. We're going to focus on this fish tank for the example. We're going to start with something called density-dependent factors. Well, what's density have to do with anything? Population density simply means the number of individuals that make up a population. So, for example, we have these guys. These are the shell dwellers. The shell dwellers are only 2 of them left because one of our limiting factors took a number on these guys this weekend. You remember in the last video I said there were 6? Well, something happened that was a limiting factor that kind of dropped their numbers, and we'll get to that in a moment. But a density-dependent factor depends on the number of organisms in one population or another and how they affect each other. These guys are gelitochromis, so they are a different species of fish, which is pretty obvious just from looking at them, right? Well, one of these density-dependent factors is called competition. In this tank, there is competition for things like space. There's competition for things like food. There's competition between each other for those resources, right? Those are density-dependent factors. Other density-dependent factors may include things like predation. If this one fish right here, this big guy, was even bigger, he might start looking at these guys and thinking they're food. Right now, he's nowhere near big enough to do that. There is also a density-dependent factor in parasitism and also disease, which I believe is what's responsible for taking some of these guys out. Again, there were 6 of these shell dwellers, and there's only 2 left, and I think they had some kind of disease that was running through them that I've since medicated them for, and these 2 appear to be doing much, much better. Right there, see that little action there? Competition for space. The bigger fish chase the smaller fish out of his area. These are all density dependent because they involve at least 2 biotic factors working against each other. And if we remember, biotic factors are living factors. So generally, anything that's density dependent, that depends on the density or the number of an organism in its environment, that's going to be a biotic related factor. After that, we have density-independent factors. Well, what's independent mean? It means they're independent from other organisms. It generally involves one biotic factor or one organism's population with an abiotic factor or a non-living part of the environment. Well, what are some examples of density-independent factors or abiotic factors that are limiting? Well, you've got climate. Their climate's relatively stable here. They're in a small fish tank. You've got water. Well, the amount of water is a limiting factor. This is a 20-gallon tank, so they only have 20 gallons of water. And even then, that's not that true because all the rocks and all the substrate in here, the substrate just means the sand and the gravel on the bottom, that takes up space. Space is another abiotic factor. By taking up that space, there's probably closer to maybe 18 gallons of water in here because those rocks probably take up the space that water would normally fill. So that's a density-independent limiting factor. There's also things like natural disasters like fires and floods and earthquakes and such. These guys probably won't experience any of them, but a natural disaster in their case might be the power goes out and they have nothing to fill the water with oxygen from their sponge filters. Their heater in the back there, that long silver tube, this thing, it might not be able to turn on and they might become too cold, which is temperature related. Temperature is another independent density factor. And then you've got, of course, me. I am the human activity aspect of this tank's ecosystem. What I do as an independent density factor is I feed the fish. I clean the tank. I supply them with fresh water, with water changes that normally would happen with rain in the wild. I supply their tanks with oxygen by pumping air through these sponge filters. Without me, a lot of the abiotic factors in this tank would become stagnant, toxic, and probably kill the fish. So as a result, we end up having a list of these kind of components. We have our density-dependent factors. Dependent on other organisms. Your examples are competition, predation, parasitism, and disease. All involve organism versus organism factors. These are biotic. Okay? After that, we have our density-independent factors. These are independent or separate from other organisms. These are examples: climate, water, temperature, space or territory, natural disasters, fire, floods, earthquakes, etc., and human activities. You'll note there's a little asterisk beside that. Sometimes human activities are density dependent. Things like mosquitoes. The more people there are, the more food they have. So in that case, we would be a density dependent. But for the most part, the stuff that humans do in an environment falls under this category. These would be abiotic factors, non-living factors. Remember that human activities, while we are a living thing, we indirectly affect the non-living things in a lot of organisms' environments. If we burn down an entire forest, we weren't the ones majorly causing that, but we might have started it. So we started a major density-independent factor for limiting a population of organisms. Hopefully that will give you guys a little bit more background. What I want you to do for today's quiz is to take notes on the material we covered, specifically on the note page that I gave you, and keep in mind the examples that I used. What was my role in this scenario? What are some of the abiotic factors in this fish tank? What are some of the biotic factors in this fish tank? And would they fall under density dependent or density independent factors for these limiting factors? As always, guys, stay safe, wash your hands, and have a great day.